Hi, and welcome to this Dimecast episode about working in iOS with both Objective-C and Swift. In reality, it isn't as hard as it may seem, but there are plenty of gotchas. Even as I was preparing to make this recording, I got sent down a lot of rabbit holes, and a lot of the code samples on this topic were vague, so I had to do a lot of trial and error. Hopefully you find this Dimecast easy to understand and get value from it. Remember, as with all of my Dimecasts, you can find the link to the code in the show notes, or just find my Dimecast repository on GitHub under my username Pete Shearer. If you haven't yet watched the earlier Objective-C and Swift Dimecasts, or you don't have any prior experience, you should consider watching those Dimecasts if you find some of the code in this example confusing. Let's get started. So first, we're going to create a new Xcode project. iOS application, single view application. We're going to call it Swiftly Objectifying. We'll make sure the language is Swift, iPhone, next. We'll save it in the Dimecast folder. Right away, let's create our core Swift class that we're going to be using to double a number for us. So I'm going to right-click, New File, Swift File, call it Swift Math, and save it. So I'm going to declare the class. It's called Swift Math, and it's going to derive from NS object. That makes interop easier, and we'll take a look at a different way we could do this at the end. And I'm going to create my method. So there it is. Basically, we just take an integer and we double it. Nothing too complicated here. I could make this method and the one we're going to do later in Objective-C class level methods, but I wanted to show you how to declare objects across the languages. Now, let's make an Objective-C math file that's going to consume this Swift one. And again, I'm going to right-click, New File, Cocoa Touch class, next. Call this one Obj-C Math, subclass of NS object, language, Objective-C. Now the first thing it's going to ask us to do is it's going to ask us if we'd like to configure an Objective-C bridging header. What that means is that there will be a header file that will make Objective-C available to be used in Swift. We want to say yes here. So you notice it creates our Obj-C math.h and .m files, but it also makes a swiftly objectifying bridging header .h with hyphens between the words. And if we look under our project files properties, under build settings, you'll notice there's a property called Objective-C bridging header, and that's set here. You can actually create your own header file. There's nothing really special to it if you just create a new file, new Objective-C header, and then come to this property and add its name. Don't forget project name / and then the name, or it will not find it when it tries to compile. I struggled with this one for a while, so just wanted to give you that heads up. Let's go back to the bridging header. We're going to include the header for Objective-C Math so that Swift can ultimately know about it. And that's all it takes. Now, in Objective-C math.m, we need to import our Swift math file so that Objective-C can do something with it. You notice we didn't create anything like that in a bridging header, and while we had to make an Objective-C bridging header, Swift automatically gets headers made for it, so we just have to know that pattern. In this case, it's just project name -swift.h. It's not the file name or the class name, it's just all of Swift automatically becomes available when you reference, or all of your Swift files automatically becomes available when you reference this header. So let's get to it. In the implementation, I'm going to declare this code. You'll notice what we have here is that we've declared a type of type Swift math, which I've called a pointer math, and we just call the new method on Swift math. And then I make an interim result. This part's just the math. This is the Objective-C math portion where I just square the number, store that in an interim result, and then I pass the double it message to math, giving it the interim result as a parameter, and I return that from the method. Now we just have to make this header, or this method, available in the header. And now we can come to View Controller. So you notice right away, I can declare this variable of ObjectiveC math equal to a newed up ObjectiveC math. I didn't have to add any header in the View Controller file because it was already in our bridging header. So from there, I can just call the square and double, just like a method. And lastly, I can print that out. So I'm going to just print line, pass out squaring and doubling 5 gives us, use string interpolation to to pass the result out to the console. And now we can run the code. Okay, now that the app's run, we didn't add a UI, but let's jump back to Xcode. And we see down there in the console, squaring and doubling 5 gives us 50, which is the correct answer. And our code is successful. We started with a Swift file, consumed that in Objective-C, and then turned right around and consumed that Objective-C class in Swift again. Before we go, I want to show you another way that you can share your objects from Swift. If we go back to our original Swift math, you'll remember that we had to derive from NSObject. Perhaps your Swift classes are already deriving from another object, or you just don't want to take that dependency on NSObject. There is another way to do that. So we'll get rid of NSObject, and I can add before the class keyword at ObjC, and that now makes this class available automatically in that auto-generated Swift header. But we lose our ability to new up the class the way that we did because of the NSObject. So we have to do something different. We'll create a class level method, an initializer, called classFunc. In this case, we'll just call it new instance. Make sure it returns Swift math. We are just going to return a new instance of Swift math. Now we just have to go back into the Objective-C math, and instead of calling Swift math new, we'll call new instance instead. Now if I run it again, you'll see that it runs, and again, we get the same result, no problem. So as you can see, it is a little easier to inherit from NSObject, but you do have a lot of control if you need to use it. That's it for this episode. You've learned how to call Objective-C from Swift through a bridging header. You've seen how to call Swift from Objective-C from the automatically generated header. And you've seen 2 ways to declare your Swift objects so that they can be constructed in Objective-C classes. Until next time.